Okay, so this is a lesson on 8-4, which is graphing quadratic functions. When we're talking about this section, I know there's a lot of steps that are written here, so you probably want to go ahead and pause this. But I'm going to try to make the most sense of everything as I can. I'm going to show you a couple examples, and then in addition to the examples here, I'm going to show you how you can use the Desmos calculator on your iPad, which I had you bookmark the other day onto your home screen. Okay, so first let's talk about the steps that you actually need to use to graph the quadratic functions. Your first job is, well, make sure it's in standard form so that it's in descending order. So the x squared term followed by the x term followed by the constant. Then you need to identify your a, b, and c. And in identifying your a, b, and c, this is something you had to do for the quadratic formula. After that, you're going to use part of that to find the axis of symmetry. And the formula you're going to use to find the axis of symmetry is x equals negative b all over 2a. And hopefully you recognize that as a portion of the quadratic formula to those crazy songs that we learned in class. But that portion of the formula is used to calculate this axis of symmetry. And an axis of symmetry is basically like an invisible line drawn down the middle of a parabola so that points on one side of the parabola are mirrored to the other side. Step number 3 says that since we can have a function of x is really y, we can rewrite the function as a y equals equation and then plug in the value that we found for x in step 2 to find a value of y. Step 4 says that ordered pair is now our vertex. So that's going to be either the bottom or the top of our parabola depending on which way it's facing. That's going to be the first point that you'll plot on a graph. Step number 5 says to graph your vertex point and the axis of symmetry as a dashed line on the graph. So you're just going to draw a dashed line right through the center of that point. Then you're going to use different values and the axis of symmetry to get at least 5 points on your graph. So you'll already have the vertex. You'll need 2 additional sets of points. On here it says you can use the table function on your calculator to help, which works on a graphing calculator. But I'm also going to show you on Desmos how you can do that with the table function to make things a little bit easier for you. Okay. All right, let's go on to the next section. A couple things to remember. The axis of symmetry is always going to be a vertical dashed line. Again, it acts as a mirror. And quadratic functions can form 2 types of parabolas. We have a parabola that faces upwards. This is when our x squared term is positive. And when the x squared, or when the parabola faces upwards, the vertex is at what's called a minimum point. So it's the lowest point of the graph. When the parabola faces downwards, this is when the x squared term is negative, and that's when the vertex point is at a maximum. Okay, so let's look at example 1 here. Example 1, we're given the equation f of x equals x squared minus 4x plus 5. Our first step is to identify our a, b, and c. So a is equal to 1, b is equal to negative 4, and c is equal to 5. Then we're going to take those values and plug them into our formula for the axis of symmetry. So x is going to be equal to the opposite of b, which would be 4, all over 2 times 1. And 4 over 2 is just equal to 2. So then we're going to find our vertex. And we're going to find our vertex, if x is 2, we're going to plug 2 back into the original equation up at the top and solve for y. When we do that, we will end up with our vertex ordered pair. So go ahead and take 2 and plug it back into the original equation and see how you do. When you plug it in, you should end up with 4 minus 8, which is negative 4, plus 5 is 1. So our ordered pair for the vertex is 2, 1. So that's where the first point on your graph is going to go. Then we're going to go ahead and we need to graph the axis of symmetry. So we're going to draw that dotted line straight through that point to make sure we know where our mirror is. And then we're going to find 2 more sets of points. The easiest way to find another set of points is, since our vertex is at 2, 1, you want to go 1 point just to the left, and that would be the x value of 1. If x is 1, we can plug it back into the original equation and figure out what y would be equal to. So if we plug in 1, we end up with 1 minus 4, which is negative 3, plus 5, which is 2. So our next ordered pair is at 1, 2. So we can plot that on our graph. And now, because we have that axis of symmetry line, this is where finding some other points on the line become a little bit easier. Because that point we just plotted is just to the left of the center of our parabola by 1 space, the point that's on the other side of the parabola, the mirror image, will be 1 space to the right and on the same line. So at the point 3, 2. So we're going to repeat that one more time and find another set of points. So we already plugged in 1 for x. So again, we're just going to move left one more space and we're going to plug in 0 for x. And when you plug in 0 for x, you end up with a 0 minus 0 plus 5. So our next ordered pair for a location of a point on this parabola is at 0, 5. So we're going to plot that point, and now we can use our axis of symmetry again to find the mirror image of this point on the other side of the parabola. The point we just plotted is 2 spaces away from our axis of symmetry, so the point on the right needs to be 2 spaces away on the right of the axis of symmetry. And once we have our 5 points, we can graph the parabola, and this will give us as pretty close to a true shape as we're going to get on a graph this small. Okay, I'm going to go over one more example a little bit with you, at least with finding the vertex, and then we're going to jump over to Desmos so that I can make sure we know how to use the table function on there as well. It's important that we try to figure out a little bit of a way to use technology to help us with the graphing process of this. Okay? All right, so example 2, we have f of x equals x squared plus 2. So it's in our descending order. We need to identify our a, our b, and our c. So our a is 1. Well, I don't have an x term in this problem, so that means my b is 0, and my c is 2. The formula for the axis of symmetry, though, says the only things I need are the opposite of b all over 2a. So I end up with 0 over 2, which is just equal to 0. So I know my x is 0, so I need to find out the other part of the ordered pair for my vertex. So I'm going to plug 0 back into the original equation, and I end up with 0 plus 2. And 0 plus 2 is 2. So my vertex is at 0, 2. And then go ahead and draw your axis of symmetry. After you've drawn the axis of symmetry, now we need to find additional points on the line. So this time our vertex is already on the x equals 0. It's on that y-axis right there. So we're just going to go 1 point to the left, and we're going to plug in x equals negative 1. And I want to know that when x equals negative 1, I want to know what my y value is equal to, and that will give me the location of another ordered pair. So the location is, if I plug in negative 1, I end up with 1 plus 2, which is 3. So my next point is at negative 1, 3. And because that point is just 1 space to the left of my axis of symmetry, the mirror image would be 1 space to the right. Okay, we're going to do that one more time to find that extra set of points. So I'm just going to move 1 space to the left again, because remember, a parabola keeps going up and out. So that's why I'm moving left to find another point. So I'm going to plug in negative 2 for x and simplify. So negative 2 squared is 4, and 4 plus 2 is 6. So my next location is at negative 2 and 6. And again, this is where the axis of symmetry comes into play because this point is 2 spaces left of the axis of symmetry. Its mirror image is going to be 2 spaces right of the axis of symmetry. And now that you have 5 points, you have the general shape of the parabola. So we go ahead and connect the points and draw the parabola.